Guys, welcome back to the channel. Today I want to go over something quite exciting which somebody turned me onto at work, and this is Pandas profiling. So this is a way to do really easy EDA. All you need is to install Pandas profiling. I'm doing it on Collab here, but you can install it on your own system if you've got Jupyter notebooks. But like very easy to install on Collab. All you need is this notebook. Essentially, you can stick your own data in and you're ready to go. So the only difference you need to make on this notebook to get Pandas profile going is just to change the read CSV data here and then put your own data on the Collab. So just going quickly what data set we're looking at. Found this UCI heart attack data set. Loads of different things in here, loads of different categories, but really it's a data set neutral. Just want to show you what this tool does, and really this is a clean data set we're looking at today. It would be really useful for not a clean data set where we didn't know much about it. So first of all, we do a pip install of Pandas profiling. I've already done this. This will install all the dependencies on your Google Collab instance starting up. So it will take it took about 20 seconds or so. I don't want to go through it on this video. So you just pip install this. And just to reiterate, everything is on GitHub, superdataworld/Python, Pandas profiling. You can just open up this notebook, open a Collab, and then you're ready to go. So all you'd have to do is change, as I said before, all you have to do is change the name of the data set in here. And I've just pulled this data set in. If you want to follow along with this example, the data is in the GitHub as well. So if you go into Pandas, if you go into Python, data, you've got that heart CSV here. So if you want to follow along, just download that and put it into put it into a Collab instance, right? So we've got our Pandas profiling installed. We're going to import Pandas. We're going to import matplotlib. We're going to, from Pandas profiling, we're going to import profile report, and then use our matplotlib inline, and then pd.set option display.max call width equals none. So this is just what we're going to do here. Is we're going to do the profiling within the notebook, which is okay, but we're also going to export a HTML file, which actually ends up on the Collab environment as well, and we can just download it from there. So we're going to run all this, and that'll just this is all our setup. Then we're going to df equals pd.read heart.csv. I've got my heart.csv here. You can pull in any file you want here and then just rename this to the name of that file. We're going to execute this, and then we're going to go this is how you would get the Pandas profiling report in the first place. So it's profile equals profile report df, which is the name of our data frame. We give it a title because the title actually comes out on top of this report, and explorative equals true, which is allowing some all our exploratory data analysis. So that's actually run now very quickly, and there's two ways to get this out. The first is profile to notebook, which will generate this in a frame, and you can see that it's starting up here, doing all its rendering it needs to do to get this out into a frame. This is just if you want to see it in your notebook. Personally, I think the export to HTML is much better. You can save it, you can share it, that sort of stuff. But here it is in a notebook. I won't go through it in the notebook, but you can see it's not the easiest thing to use and get around. So I'm just going to take this out into a HTML file. So export to HTML, you can see it'll come up here. So it's now popped up on our Collab environment. Just going to download this file, and it's popped up here, so we can just open it. And here is what the Pandas profiling is. I think this is super cool because you don't have to run all your different usual, all your different profiling executables in Pandas itself. Everything's kind of done for you. So you can see like the dataset statistics here. We can go into each variable and be able to see, right, what's the distinct, what's the missing, the mean, the minimum, the max for numeric variables. And then we can see more details. So we can see all kind of statistics. What's really useful is extreme values. So we can see kind of outliers. So we can get the minimums. We can get the maximums. And we can see the most common values. We can see a histogram of the values. So just for each point on your data set, we've got all this information here. This is a categorical variable, so this will have slightly different things. So you get to see like your categories, your frequencies like this. This is something that you'd need to run a number of commands per data point to get out, but this is all kind of laid out really, really, really nicely. Another categorical variable here, same kind of stuff. And this is like kind of multi-category here, not just for the two up above. We get to see like a nice pie chart, all that sort of stuff. Again, lots of statistics here, histograms, common values, outliers, and then it's pretty much the same for all of this. So that's a lot of different information there. Then you've got interactions, which is your scatter plots comparing your numeric values to your numeric values. So we've got obviously age, same. So this is a big old diagonal, but if we can get age to this variable, age to this variable, age to this variable, you know, it becomes very, very useful to kind of see interactions. And then, right, very important for categorical variable, or very important for this, I think this is a classification question. You've got all your different correlation charts. So you can see like, okay, what is correlated to the target and how is it correlated? You don't have to create this. You've got your Spearman's P, you've got your Pearson correlation, you've got your Kendall, you've got the Kramer. And like, you know, this is pretty good stuff. And we can get like, if you don't know what any of these are, you can get the descriptions as well. And then this is kind of useless because we don't have any missing values because it's a clean data set, but you can see how this would be super useful. How that would be super useful if you did have missing values and seeing where they were and what they were, right? So you have your head and tail done out for you. So you've got your first rows, you've got your last rows, and then you've got your duplicate rows in there as well. So, and you can get to any of these here as well, straight down into HTML. You've got alerts from the data. And you can obviously share this around with other people. So I just thought I'd share that with you today. I think it was something that we came across at work. We're doing a bit of machine learning at work. And we're trying to show people how to kind of pull different EDA and descriptive statistics from data sets. And someone's like, why don't we use Pandas profiling? And just asked the question, what is Pandas profiling? And they presented me something like this. And I think to get it up and running in Collab, you know, you don't really need much. All you need is a data set and Google Drive, and you can get these reports out. And I think it's super useful. So I just thought I'd share this with you today. Hope you find it useful. As I said, if you want to follow along, all the information is in Python on the Super Data World GitHub. I will share that with you, but you've got your data sets, and you can use any of the data sets here. And then you have your Pandas profiling and Collab notebook as well. So I hope you found that useful, guys. Any questions, ask down below, and I'll see you very soon for another Python tutorial.